Alright everyone, so as of the last video we actually had some pretty good success here. We do have the Curiosity PIC32MZ Curiosity Development Board working with a small program. We can just review that program here. Really we have a tremendous amount of config headers at the top, most of which I don't understand what it is, but it seems to work okay. We have a generic include file that reads from the configuration up here to figure out what chip you're running off of and includes the correct header file for that chip. I have a very simple delay function that does nothing but loop for some amount of times. I have a large delay function that calls the small delay loop 100,000 times, but calls the 100,000 times 20 times, so that's 2 million loops, or 2 million counts right there. Then I have a huge delay, which calls it 200 times instead of 20 times, so that's a total of 20 million loops, or 20 million counts that we have right there. So, and then we go on to the main here, so we have the math that we figured out as far as which output pins need to be enabled. Then we have, this is some old code, we don't need that. It's really just the TRIS-E, so the E block of GIPO registers. We want to set the pins 3, 4, and 6 to an output being 0, so we have 0, 1, 2, and then pin 3 here is a 0, and then pin 4 is a 0, so it's an output, pin 5 is an input, pin 6 is an output, pin 7, 8, and 9 are all inputs. So that's what we want. We converted that using the calculator over here by selecting binary, and then just going 1, 1, 1, 0, 1, 0, 0, 1, 1, 1. So that is, this number matches this number. And we find that the hex is 3A7, so put that there. This is the standard notation that we're going to use for hex. Next thing we need to do is essentially find the inverse of this. So because we want to be turning on the LEDs. This is some older code, so I'm actually going to remove that. I was dealing with a different way of setting values in these special function registers. So we'll remove that code. So anyway, so we have, do that equals that, because that really is what we're doing here. So we do the binary, and again, leading zeros for binary don't matter. So just clear this out. So it's going to be 101 and then 1000. So 101 space 1000. You can see the hex for that is 58. So 2058 turns on the LEDs. And we are using the command, which is lat for latch, the block E, and we are calling the set command for that. So this is, again, a special function register. So we are setting this in there to turn on these 3 digital I/O bits, really output bits. And we're calling this huge delay function, which is the 20 million loops. And then we are calling latch, and then E, and then clear. And what this is doing is it clears those pins and just basically sets them back to 0. And I'm not sure that you couldn't actually, instead of using latch clear, use latch set. But for this, I'm actually just putting in FFFF, which if you go to hex and you actually read what that is, FFF, it's just a whole bunch of ones. So each F is going to be a whole block of ones. So we're actually writing more than enough because there's only 10 pins. And we're actually writing 12 digits here. And really what that is anytime one of the bits is set to 1, that means it clears it. So we're just clearing everything regardless. So like for example here, one thing we could do is let's not clear all the pins. Instead, let's only clear certain pins. And that's like one change that we could make to this program to try and see, you know, how this would look, and one of the things we can you know, change to modify it and kind of get comfortable with what we can actually do. That's my way of you know, really learning how to program, is really to try various things and see what works and see what doesn't, and try and sort of expand the vocabulary of what can be done. So what we can do here, how about we don't clear pin 3? So let's just clear 4 and 6, and let's clear 4. So 4 should be in the middle, which means the center light will stay lit, and then the light at the top and the bottom will blink on and off. So that would be a 100, 1000. So let's actually put that in. Let's switch to binary here. We'll do a 100, 1000. Find out that the hex is 48. So we need to put that in 0048. So that is what we should have there. So let's go ahead and build this. Build clean. I'm actually going to put a breakpoint in here just so that we can kind of see this. Toggle breakpoint. And I still do have the Curiosity board hooked up. So let's just go ahead and debug this project on the Curiosity itself, as opposed to debugging it in a simulator. I'm fairly confident it will execute, or fairly confident that it will load. You never exactly know how it's going to work, but because we have the header, the config bits appear set correctly. That was really one of the things that was preventing us from running our program before. So a small change like this, I wouldn't think would really throw a huge wrench. Now it may not work, but it should run, compile, and load onto the chip appropriately. All right, so it did load. It says it's running and target halted, so it's halted right there. So let's check out these variables. And again, I made the distinction between the port E and the latch E. So we're going to look at latch. Okay, and yep, that is exactly what we were looking for. So we still have pin 4, which is the pin we were looking for. So it says we're really just clearing 3 and 6 here. Because this is 3 and 4, so we're not setting bit 4 here. So bit 4 is still a 1. So that means that still should be illuminated when we run. So I'm going to go ahead and remove this breakpoint. Remove all breakpoints, doesn't really matter. And hit play, and we'll see. Go ahead and run it. Yep, it is operating exactly as I would expect it would be operating. So I'm going to attach a video here at the end of what this looks like with this small change. Here we are back with the microchip Curiosity PIC32MZ Curiosity board, and you can see that the code change that we've made has caused the LED 1 and LED 3 to blink, but LED 2 remains constantly illuminated, and that is exactly what we were going for in the code. So we have a successful alteration of the code here, and it is working perfectly well. So we can see that once we got those debug headers, or not the debug headers, but the configuration bits set correctly, it really made all the world of difference as far as allowing us to start playing with the program and actually going to the point where we can actually make it do something interesting as opposed to just struggling through the configuration. So call this one another success.